This question asks us to find the derivative and then evaluate that at the point 1 and then state whether it's increasing, decreasing or stationary at that point. So we'll just work through firstly finding the derivative of this first function. So I'm going to use the power rule. That means that's going to be f dash x equals 2x. Then I evaluate f dash of 1 and I get 2 times 1, which is 2. I can see that that is positive. So therefore at the point where x equals 1, the function is increasing. Increasing because that was positive. So we'll do the similar thing for this second function here. What I'm going to do, because it's going to be probably easier for me if before I find the derivative, if I just expand the function. So this is going to be x squared. I'm going to have minus 15 on the tail, and I've got minus 5x plus 3x, will be minus 2x in the middle. Now I can find the derivative of that, and that'll be 2x minus 2. And it was just a bit easier than using the product rule from the start. I evaluate that then at the point 1, and I'm going to get 2 minus 2, which is 0. Therefore, at this point, f of x is stationary. It's not increasing, and it's not decreasing. So for the next function, before I differentiate it, I'm going to turn it into a power, which is 2x to the minus 1. I find the derivative now, and I get minus 2x to the minus 2. I've turned that back into a fraction so I can see what it looks like. It's minus 2 over x squared. I evaluate that at the point where x equals 1, minus 2. I can see that it is therefore less than 0, therefore it means it's decreasing at x equal to 1. For this next function, I've got a bracket and a power. So for this one, to find the derivative, I'm going to use the chain rule. Chain rule says the derivative of the outside times the derivative of the inside, which is just 1 in this case. I'm going to evaluate this now at the point where x equals 1. I get 3 times 1 minus 1 squared. Well, this now becomes 0, so I get 0. So that means at this point, the function is stationary. It is not increasing or decreasing. The derivative is 0. It's stationary there. Here I have two functions, one divided by the other. So for this one I'm going to need to use the quotient rule. So the derivative will be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now let's just tidy that up, get rid of the times 1s in the brackets. What I've got here is x plus 1 minus x plus 1 all over x plus 1 squared. That x cancels out, leaves me with 2 over x plus 1 squared. I evaluate that at the point where x equals 1. And what I find is that gives me 2 over 1 plus 1 squared, which is 2 over 2 squared, which is 2 over 4, which is a half. The actual value doesn't matter. What we really want to know is it positive or negative. We can see here that this is definitely positive. Therefore, at the point where x equals 1, this function is increasing, connecting it to the gradient where it was positive. Before I take the derivative of this one, I'll need to turn it to a power, so I get x to the half. I can then take the derivative, f dash of x, to be half x to the minus a half. That's using the power rule. And now write that as 2 root x here. X to the half is the square root of x. The minus means on the bottom of the fraction. So now I can evaluate that at the point where x is 1. 1 over 2 times the square root of 1. That's 1. It gives me just a half. Again, the actual value is not important. What is the sign, and I can see that this is definitely going to be positive. So I say that at the point where x equals 1, the function is increasing. And that's the end.